Hello everyone, today I'm going to represent a video on a neural network using SAS Enterprise Miner for the course data mining. The dataset used in this assignment is from UCI machine learning repository and the topic is breast cancer. The first node in the process flow diagram represents the data which makes the dataset available for modeling. One of the column is diagnosis, which will help us to predict whether the cancer is malignant or benign. I've converted this categorical variable into a binary one, m being 1 and b being 0. The input of this network consists of 9 features. I have removed the other columns, and this 9 column expresses the different features of the tumor. We're not going to use the ID as this represent the ID of the patient. My first concept will be model selection. As we all know, machine learning is broadly divided into supervised and unsupervised. I'll be using the supervised learning, as in supervised learning both input and desired output are given to the model, and it's used to classify and provide learning basis for the future data processing. The supervised learning can be further grouped into regression and classification. Since our model is predicting the cancer, I have chosen the classification model. Next node is the data partition mode, which divides the data into training, validation, and testing node. Training is used for preliminary model fitting, and validation is used to select the optimum weight. The test is used to test the model. As you can see, the percentage of training, validation, and testing is 50, 25, 25. My concept number 2 is internal variable section of impute node, which is over here. Here, we have to set a default value as median. This will help us replace the missing values by the median of non-missing values. Median statistics is less sensitive to the extreme values, which we called as outlier, than mean and mid-range statistic. Median is also useful for replacing values in slightly skewed distributions. After that, after imputing and replacing the missing values, we should consider transforming the values before we submit our model to neural network. My third concept is transformation variable. Transformation variable is used to stabilize the variable and remove the non-linearity, which can lead to a better fit model. As we can see in the formulas over here, there are some of the variables which have value which is slightly right skewed, like areas and compactness. This right skew value can be removed by a common log transformation. This screenshot represents a log transformation of 6 variables that was slightly skewed. Any one of the bar is selected of one single variable will reflect relevant information in the other variables. Let's go back to our model again. After the transformation variable, we are using a logical regression algorithm for our model. We have selected a model as in the regression. We have selected it as a stepwise variable, which makes it a logistic regression. Otherwise, it will be a default linear model. My fourth concept will be a variable selection. It's a good idea to reduce the number of input variables submitted to neural network. Variable selection is used to perform this task. We will reject the input variable that have low R-square value, which in turn reduces the number of input variable to be analyzed. As we can see in the screenshots over here, after executing a variable selection, these are the variables which got rejected because their R value was small. It's smoothness, compactivity, etc. After the regression model, while selecting a neural network, we have selected our network. The direction connection is yes. This will enable the network to have direct connection between the input and output. When we execute the result for the neural networks, this is the output that we get. So as we can see, there's an average square error for training and validation, and the cumulative lift for both of them is almost similar. This is the classification of both the networks. It says there are these many positive values. Event classification table. This is a distribution of training data set and a validation data set. These are our fit statistics.